right, welcome everybody. We're going to talk about digital consoles now. So you've learned a little bit about the analog model, which is where we were for a very long time. And we got a very long way for a very long time with those. But as digital audio started to mature a little bit and get fast enough, we started to think about what we could do, all the things we could do with it. And it was really about that. It was really about the speed that was bottlenecking us for a little while. I mean, we've known how to do digital audio since like the 50s. It's just, you know, at what point can the chips get fast enough to push all the bits around that we need to push around? And some of the early attempts at digital consoles were pretty interesting. Yamaha has been pretty far ahead of that game for a long time as far as like putting digital consoles in the hands of end users that, you know, can actually use them. There was, what was it called? The ProMix or something was, I think, their first kind of consumer one that they put out. I played with one of those in high school. And that was kind of fun. And the principle here is, you know, with analog audio, the sound is basically converted using a microphone or any number of things we would call transducers that convert the sound in the air into a voltage, alternating current kind of voltage wave, right, that you can send down a wire. And you have to maintain a consistent electrical path for that signal before you get it back into a new transducer that can convert it back to sound. And what I mean by a consistent path is ultimately, even though it goes through the box, you know, that box has to keep that wire connected all the way through as it goes. So the analog consoles, you know, literally there was a wire linking all the controls as they go down that channel strip. Boom, 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 boom. Comes out of that fader, and there's another wire that goes, go over to here, where it mixes together on that master fader, and then it goes out. It's this continuous connection, right? And because it had to be a continuous connection like that, that forced some of the user interface things that you see on analog consoles. That's why the concept of channel strips existed, was because we had to maintain that continuous connection. We couldn't scatter controls anywhere we wanted. We had to keep them lined up because we had to keep the connections. We couldn't compromise those connections. And that meant that if you wanted more capacity in your console, you just had to add more of those slots. And you know, there were some consoles that were built to be essentially infinitely scalable. You know, you could just continue slotting in little channel strips into them until they took up, you know, the entire room. And if you go see like Wicked on Broadway, you'll see an example of that, that model. That's because that show, when that show opened on Broadway, it was using an analog console called a CADAC J-type, which is one of these kind of like infinitely scalable analog consoles, and you just like keep popping modules in, boom, 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 and it like literally takes up the whole back row of the theater. So the idea behind digital is you take that analog voltage signal that represents your sound and you convert it into data, right? That is a continuous stream of digital data, zeros and ones, okay? We're not going to get into how that works in this class. You'll learn a little bit about that in some other classes as far as what digital audio actually is, like how is that conversion happening. But it's ultimately just data. And because it's data, it just goes through the computer chip now. And what kind of options does that give us? Well, if it's just data on a chip, then we're not subject to any of those limitations anymore that we used to be subject to, where we don't have to maintain that continuous analog signal path all the way through. So So we could theoretically break apart some of our user interface concepts because we're no longer tied to this physical constraint of signal path, electrical signal path. Because if there's just a computer chip in the middle of this thing routing all that data around, it can route it anywhere it wants, right? It doesn't have to, it's not constrained by anything. But that also means that the little faders and buttons that you interact with, the signal's not actually passing through those, right? It's not doing that. The audio signal is not passing through this fader. This fader is just a controller that talks to the computer chip inside. And you move the fader and you say, hey, I just moved that fader. And the computer chip's like, cool, got it. And then based on the software, it then does something with that information. But the sound is not physically moving through this fader anymore. So what that gives us the ability to do is, okay, we now don't necessarily have to have a control, a tactile control for every single controllable parameter in the console, which in the analog world we did. If you had a 12-channel console, you had to have 12 faders, and you had to have 12 gain knobs, and you had to have 12 full EQ things, right? Because the signal had to physically pass through those things. But because the signal doesn't have to physically pass through the controls anymore, you don't have to have a control dedicated for everything that the console can do. Which means if you want to scale it and increase its capacity, that doesn't necessarily mean it has to get physically larger. It just means you have to put a beefier computer chip inside of there that can handle more data. And you write software that allows it to handle that. But you don't necessarily have to add more physical controls. Okay, you could have a small set of physical controls, and from moment to moment, you can be deciding what parameters in the console those control, right? And you see over here an example of that. So, like right now, these 8 faders are the flexible ones. And right now, they're mapped to these 8 faders. See that? But I can make them do these 8 faders instead, right? Or I can make them do those faders over there. See how that works? I could make it do that.
Could you do multiple at the same time?
Kinda, but not the way you're thinking. Okay, we'll get to that in a minute. The closest thing to what you're talking about is what's called a DC, they call a DCA, and you can kind of get it to do that. Not exactly what you're thinking, though. Okay, so that, as a concept, kind of frees us up, doesn't it? Like, okay, well, great. I don't actually, like, we could build a version of this console that didn't have any of this, right? Because we can get to everything right here. This could be the whole thing if we wanted it to be. And we could still do it all. So if that's the case, then why is it like this? Well, because of old codgers like me. Because the first couple of consoles that Yamaha put out that were digital consoles, this is how they basically worked. They didn't have dedicated controls for every channel. You know, they had layers and stuff, and they call them layers, you know, that these banks of controls that can be rerouted to control different things. And that was great, and they worked really well, and they got a really good hold in studios, recording studios and stuff like that. But they were having a little bit of a hard time grabbing a hold of the live market. And part of the reason why is because there were people like me who had come up on the analog consoles, and part of like what made that make sense to us is that we could see everything. We could look at the console, we could say, I know what's happening, right? I can see all of it. If there's a channel that gets away from me, I just have to look and I'll see it. But if this is the only thing that I'm looking at, and this was all gone, and right now I'm using this to control these channels, if something over here starts freaking out, I'm not necessarily going to see that. And that made the people like me that do live shows very nervous. Like, I can't see everything. And I'm doing this in real time. Like, I'm not a studio person who gets to do 100 tries at this until I get it right. Like, it's happening right this second, and I either get it right or I don't. There's no do-over on the live show, okay? And so that made us very nervous. And so Yamaha, in all their infinite wisdom, said, okay, fine. We will give you what you want. And what we wanted, and I was one of the people that was saying this, I want to be able to see everything. And they said, okay, if that's what it's going to take to get you to buy one of these, then we'll do it. And so they made this console. And this console, this is a 48 input channel console. How do I know that? Because it has 48 faders, okay? Which is how the world used to be. The world used to be, when you bought a 24 channel console, you darn well got 24 faders, you know? And, you know, we were very nervous about it. You know, I'm not buying a 96 channel console if there is not 96 faders, you know? It's like, I paid for every one of those faders. I want to see them, right? And we needed that because we had learned this paradigm that was very difficult to change our brains around for, okay? But here's the problem. I kind of think we may have gone about this the wrong way. Because once we went to this digital model, none of those user interface paradigms mattered anymore. And yet we still stuck with them. So this is still, this little screen here still looks like a channel strip. It still is faders. It's still, like, we didn't reinvent the interface. We just said, well, the interface is fine, it just doesn't have to be constrained anymore. So we were standing in front of something that was presenting information to us in the way that the analog consoles presented information to us, but it didn't let us see all of the things. And I kind of wonder if we hadn't have like just reinvented the interface in that moment, if we wouldn't have gotten a little farther sooner. I'm not sure. But anyway, that's what's going on here. But what this means is we kind of, so this thing comes out, and Yamaha sold 10 billion of them. You know, because all of us were like, finally, okay, this I can wrap my head around. Okay, this will work. I can see everything. And they're like, yeah. They're like, well, you know, we can't give you the whole channel strip for them, but we can at least give you the fader. We can give you a meter for each of them. We can give you the channel enable. And we can give you a PFL, which they're calling Q for some reason. You know, because Yamaha. And they're like, so we can give you that, but the rest of the stuff, you're going to have to deal with this screen. And we're like, okay, well, that's fine. I think we can deal with that. And they're like, so we're going to give you these 8 faders that are not tied to any channels particularly, and you use this to get at the details. So you can see the overview, but you want to get into the detail, you got to pull those channels up onto here, and then you can see it on the screen. And we've given you these knobs you can turn, and it just depends on which of these channels you have selected, what these knobs do. Okay? And we were like, okay, fine. We can wrap our heads around this. Well, here's then what happened almost immediately. Yamaha sells 1 billion of these, and everyone's got them, and then suddenly we're all like, well, it wasn't why do I need all these faders, it was like, well, wait a minute, why is this thing so inflexible? Why am I constrained? I feel like I am being constrained in ways that I don't need to be constrained. And what that means by that is like, okay, look in the back of this console. There are 48 analog XLR inputs, okay? Plus the 4 stereo ones. And then there's the 16, what they call the Omni outs, which can be anything for output wise. We'll talk about that in a minute. But we're going, okay, but I have these expansion card slots where I can, and Yamaha was selling these card slots that would allow the console to talk to different kinds of equipment. Like we've got a Dante card in there right now. And they were selling like extra analog input-output cards. They were selling ether sound cards, CobraNet cards. They were selling ADAT cards. They were selling Waves plug-in cards. So we had these 3 card slots that we could put things in that would expand the capabilities of the console, or could expand the capabilities of the console. And so we're going, well, wait a minute. I've got these card slots. Why can't I put a card slot on there and get myself 16 more inputs? And they're like, well, you can. And because like now you have 16 inputs that can talk in a different way. Yeah, but I want to add 16 more channels to this thing. Why can't I do that? There seems to be no good reason.
You wouldn't have anyone to see it?
Exactly. And Yamaha said, well, you said you wanted to see everything. And if you want to be able to see everything, then we can't give you the ability to add things you can't see. I was like, well, okay, but
I want to see them.
now I understand. Right?
What you were talking
That's what I get. Okay, I get it now. I get it now. Okay, will you please make me something that,
I can have all my channels and see.
yeah, and so I was like, okay, maybe I don't need to see everything. Like, actually, I've been surviving just fine, and honestly, I never really look at these, I just look at this, you know? And so that's when they started making some different things, right? So they put out the LS9s, which had layers back again, which that was a concept they'd had before, and they brought that back.
The LS9 is newer than the M7?
Yeah,
No way.
yeah.
Wow.
That's impossible.
Would not have called that.
A little bit newer, not a lot. I mean, they came
Yeah.
out in their same generation, but this came first.
I mean, they nixed a touchscreen too. Like,
Yeah, yeah. And so,
Right?
why?
so that the LS9 hit, and we're like, oh, okay, yeah, layers, great. This is familiar. I remember that. I remember thinking that was a dumb idea, but I'm acting like, you know, this is the way I was thinking, and I know there was a lot of people that were thinking the same thing. I don't think everyone is necessarily, but I'm presenting it that way because the universe revolves around me, right? That's how that works. Anyway, so I'm thinking, okay, well, yeah, okay, I remember this layers thing. I can do that, right? So then, you know, so it was this M7CL, the LS9, and the PM5D, and the PM1D that they made, that that was all kind of happening around the same time. And the M7 was this fixed format thing, and everything else was able to do this kind of flexible stuff. And so, but these, like, they literally sold just a ton of these. I mean, you see these everywhere. I mean, walk into any performing arts venue, they either have one of these in their booths or they have one in the basement now. You know,
One of the places I was in last week in the middle of nowhere, Texas, had one.
everybody has them because everybody has them. All right, we have 3 of them. Anyway, so that's kind of the basic idea. That's where we went. But I wanted to start with this one because I think it's an interesting. It is an interesting transition from that analog conversation to the digital conversation, because we can talk a little bit about the kinds of flexibilities that you get when you go to digital, but we don't have to talk about it in as abstract concepts as we would have to with some of the other ones, because some of the other ones you literally can't see some of the things it can do. And so you have to think abstractly about those things since you cannot see them. But in this one, we can see them. And that was the point. So we're going to start here, all right? So let's talk about some of the things that moving to digital gets us. Well, you remember when I said on an analog console, every control that you add costs money and space. right? Every channel of EQ you want to add to that strip costs money and space. And we talked about how the answer to that was inserts. Okay, and how you can plug in, like, to that insert connection, you can add things like a compressor and a gate and a reverb processor and stuff like that. Because building that into the analog console would be very expensive and would make it even bigger than it already was, which was already too big. Okay? Well, in the digital world, we're not constrained by that anymore. You can add capability without taking up more space, right? You do have to, the computer chip has to be capable of processing that extra information, and you have to be able to write the software that will do that. But once the signal comes in and gets converted to digital, at that point you can really do whatever you want to it. When you're making changes to the sound, you're just doing mathematical operations on it, and you could just as easily do a mathematical operation for compression as you could do a mathematical operation for, you know, gain going up and down, or something like it. It's just math, so it doesn't matter. So guess what? Here's this console that has, we have gain, we have phantom power, we have polarity inversion. You can see it up here, right? So we've got gain, we've got phantom power, we've got polarity, we have high pass filters. We do have the ability to do inserts. We do have the ability to do direct outs. That is possible, and we may get to that. We have an EQ, and we have two dynamics processors. And dynamics processors can be things like gates, compressors, limiters, expanders, things like that. So dynamics processors, right? We'll talk about this mess in a minute. We have PAN. We've got, you know, your main stereo group routing, right? You've got your channel enable, disable, which is what it actually is. It's not a mute, and you've got your fader, right? Great. Well, guess what? Some of this stuff wasn't in the analog console, was it? We got those dynamics processors for free, and it didn't take up any space. And look, it's easy to get to it. So, you know, if I want to. If I want to compress this thing, I can pull this up, and here's a compressor.
Oh, cool.
And I could say, all right. And turn it on, and now it's compressing. Compressed kick drum. Let's see if I can make it sound more compressed. There we go. Compressed kick drum. Okay. Cool. I didn't even have to patch anything. Right? I didn't have to get something. I didn't have to rack something up in a rack. I didn't have to like cable and do the weird insert funny wire thing. It's just in there. Awesome, right? That's something that digital gets us, is you can add functionality without it costing a ridiculous amount of money or a ridiculous amount of space, okay? So that's one of the things that gets us. Let's talk about, let's just go through these controls one at a time now. So we have the physical inputs, right? And that is an XLR. Notice if you look on the back, there's no 1/4 inch inputs like the other one, right? It's all XLR, which is why people like me liked it. Because I was like, yes, XLR, way better than 1/4 inch. 1/4 inches are terrible connectors. XLRs are way, way better. So it's all XLR. And if we pull up the settings here for the gain, let's see if I can pull it up here for all of you. All right. So here is channel 1, all right? So for gain, that's what I got. Look, I start at plus 10 dB, and as I turn up, I can go all the way up to minus 62 dB. Well, what's that? Why is the number getting lower as I turn it up? Well, they call this a head amp, not a preamp. And that's because there's an interesting little circuit going on in here. You remember on the analog console where we had to use a different input for a line level signal because we had to put that 20 dB pad on it? Some consoles will give you a button to do that, some analog consoles. This one just gives you one big long knob. And the idea is there is really two things going on here. There's a relay inside that switches between the two things. So the part of the circuit that can deal with the line level signal is one thing, and then the part of the circuit that deals with the mic level signal is a different thing. And they've figured out a way to consolidate this into one controls and one connector. So you just plug in and it figures it out. And what you're seeing here, that plus 10, that is dBu, and it's referring to the strength of the signal coming in. So if you are getting a plus 10 dBu signal that you're plugging into this thing, you're going to turn this thing all the way down. Well, at some point, and you can, if you listen, you can hear it. Come stand over here. Come stand close and see if you can hear it. You ready? I'm going to turn this up and tell me what, listen for the click. Did you hear the click?
Yep.
Okay, what's happening there? There's a little relay that is going, oh, wait a minute. We've crossed a threshold to where now we're dealing with a microphone level signal. So there's this mechanical relay that goes, what? And moves that signal over to now go through a mic preamp, okay? And so it's one knob to rule them all. And you can crank it up as hot as you want. And at some point, it becomes a preamp. And so if I take it all the way up and it says minus 62 dB, that means I am feeding it a minus 62 dBu signal, which is going to be a really, really quiet microphone, okay? So that's what's going on there. But the same principles apply. You turn this up as hot as you can get it without clipping. However, just understand that digital clipping is bad. I mean, analog clipping is bad too, but digital clipping is really bad. Analog clipping, sometimes you can live with it, but digital clipping sounds pretty awful. So you really, 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 really do not want, I mean, you never want it to clip, but you really, 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 really don't want it to clip in digital, because that sounds really bad, okay? And so there is a camp, of which I am not a member, that says, well, because you really, really, really don't want it to clip, then you really should be a lot more conservative about how high you crank this head amp. And I'm going, well, yeah, but I understand how digital works, and digital likes having a wide range just as much as analog does, and I want to give it as much room as I can. And so I'm still in the camp of like crank it up as hot as you can get it without clipping. And I spend most of my time, like when I'm teching a show, like I just came off of Annie, I spent most of that time watching inputs for clipping. And because I really want to get that as hot as I can, but I don't want to clip it, all right? So same principle still applies in my world, okay? You might find people that tell you different, but you're paying for my opinion right now, so I'm going to give it to you. All right, so then you've got your phantom power. If you do need to turn on phantom power, you have to kind of click the little, there's a touch screen here, you have to push the little knob there, or you can hit it here, and you get the channel overview, just like you have up on the screen here. But to get to that phantom power, you have to open up this little screen, and you can turn it on there, right? So the only way to get the phantom power is with that little touch screen. Same thing with the polarity inversion. You can get it there, or you can go to the overview and you can do it here, and you get a whole row, and you can flip on the phantom powers there, or the polarity inversions there. Okay? Everybody doing okay? Questions so far? All right. So great. The next thing that we hit is the EQ section. And this is a 4-channel EQ, which you can see here. But what's interesting about it is we get variable bandwidth on this, which we didn't have on the analog console, because that would have required an extra knob, and more knobs are more space and more money. And it doesn't cost us anything to add a variable Q here. So yeah, we can, but the other thing we get is we get a graph that lets us see a graph of what we're doing to the sound, okay? And this is very important. The graph does not tell you what it sounds like. The graph just tells you what you did to it. Okay? It does not tell you the result. Right? It just tells you what you did to it, but it does not tell you what the result of that was. Right? Just because you decide that you're going to do that, that does not mean that the sound now sounds like it has no bass. Okay? That it doesn't necessarily mean that. It just means you reduce the bass a lot. Okay? Very important concept. A lot of people mistake that. All right, but you can see what you're doing, which is super cool, right? Look at that, I can see what I'm doing. So when I say you get variable bandwidth, what I mean is this, where I can control how wide of a range of frequencies I'm affecting here. That's super useful. And then I can still control which frequency is the peak, right? But then I have this cue that allows me to get very, very precise or very imprecise, which is very useful. I'm in the camp that says, if you're not affecting at least an octave range of frequencies, you're not doing anything. Okay? If I ever walk up to your console and I see something like this, I'm going to be like, what are you doing? What fantasy have you created in your mind?
It's the feedback.
You know, what is this world that actually changed anything at all that you can hear, you know? Because our ears just can't hear at that kind of resolution. So if it doesn't look at least like that, I'm like, you're not doing anything. You are twiddling knobs to twiddle knobs and feel like you're doing something. But you are not doing anything at all. I'm also of the camp where, you know, you really only need 2 bands of EQ. If you need more than 2 bands of EQ to get that sound to sound right, you are doing it wrong. Okay? You just don't need that. You don't need that kind of, when you're doing it by ear, you don't need that kind of precision. Now, yeah, if you're like doing an analysis system and you're doing really fine tuning, like, okay, maybe. But when you're EQing things by ear, you're just tuning it. You're just like, and if you're using more than 2 bands of EQ, you don't know what you're doing. I mean, you are doing more harm than good, probably. Okay, so I like, and it's all fine and good to have the 4 bands, but I usually only ever use 2. But what's interesting about this also is you can, well, there's a high-pass filter as part of this, but it has a variable cutoff. Remember, the other console didn't have that. No, it did it? I don't remember. It was fixed. So this one you can mess with, which is pretty cool. And honestly, this high-pass filter thing, this is the secret. This is one of those things that will take you from something that is a mess to something that is actually pretty okay. Okay? Most of the mixes that sound terrible, in a lot of cases, sound terrible because there's just way too much low energy going on in there. That's bleeding off of everything, and you know, you go look at any of my shows, and you will be shocked at how aggressive I am being with these high-pass filters. I mean, I am taking these I mean, it is not unheard of for me to have a 250 hertz high-pass filter on a vocal mic. Yeah, I will do that. I have, you know, Connor came and heard Annie the other night. I have high-pass filters on some of those mics that go that high, you know? So, yeah, I mean, yeah, there's nothing going on down there. Why am I adding to that mess if there's nothing there? Just like, I'm just gonna filter it, okay? anyway, sorry, that's a little diversion. Okay, but the other thing that is interesting is you can switch the high shelf into a high pass, or a low pass, sorry, I said that wrong. See how I switched it? Or I can put it back to a shelf, and now, it's that, right? So,
Clicking for that?
I'm clicking this little button that toggles it, all right? So this is just some examples of the kind of flexibility that you get once it becomes just a matter of doing math, right? It's just math, and you can do any math you want on the signal once you've digitized it, okay? Adding controls is cheap, and does not add any space, okay? In fact, you know, again, Yamaha gave us all these little knobs because we wanted them, but no one ever touches them. No one ever touches these. I never touch these. We just use these, right? It's like, I only need one knob. What is the thing I'm controlling right now? That's it, okay? But again, they gave us what we want. Okay, so we've got the two dynamics processors, and they can be either a gate, a ducker, a compressor, or an expander. What a gate is an automatic mute button. So there's a little Smurf inside the box listening to the sound, and they've got their hand on a mute button. And you say, okay, Smurf, I only want to hear the loud things. The quiet things I don't want to hear at all. Okay, fine. So when it's quiet, just mute the whole channel. But when it gets loud, unmute it, and just do that really fast. Great, that's what a gate is, okay? A compressor is, the Smurf is listening to the sound, but now has their hand on a fader. And you're like, hey, Smurf, can you, I don't want the loud things to overwhelm me. Can you just turn down the loud things and leave the quiet things alone? Just ride the fader for me, right? As it gets loud, turn it down. As it gets quiet again, turn it back up. It's all a compressor is. A compressor is just an automatic fader rider. You have Smurf to ride the fader for you, okay? A ducker, which is one of the options here. So like I've got Dynamics 1 set to duck. A ducker means if this input signal gets loud enough, just duck it for a little bit. Duck it by a certain amount. I mean, by ducking, it just means like turn it down really quick for a second. And then bring it back up again. So it's much more aggressive than a compressor. The idea behind a ducker is usually with a ducker, it's listening to something else. So it's like you've got background music playing, and you put a ducker on the music, so that when you talk into the mic, it automatically ducks the music out to a quieter level so you can hear the mic, right? That's classic use of a ducker. An expander is the opposite of a compressor. It's still the Smurf riding the fader, but you're saying, hey Smurf, can you make the louder things louder? Right? So it's like, hey, when the loud things come, I want those to be loud, right? I want to be very impressed by these loud things. So the Smurf is like, great, yeah, sure, when it gets loud, I'll just turn it up, but when it gets quiet, I'll leave it alone. Okay? So instead of turning the loud things down, the Smurf is turning the loud things up. Okay? That's what an expander does. So you have the ability to have some combination of two of those things on each channel of this console for free, basically. All right, I'm going to skip over this still for a minute because that's a whole big soapbox that's going to take me a while. Okay, so you know about pan, right? We've learned about that. You can route to stereo or not, but you also have this mono output, which is really good for things like center clusters, and you can route to that or not and get an output there, okay? And they do have this like left, center, right panning mode, which is kind of interesting, which lets you, so when you're panning left, center, right, it'll move between three outputs. But then the CSR is like how prominent is that center channel when you're doing that pan? You can decide like how.
So that's the volume for wherever you put it?
Well, it's just sort of like, you know, how big of a role is that center loudspeaker playing in that pan?
Oh, okay.
You know, it's like when I go to center, is it like only out of the center?
Got you.
Right? Or is it widening out a little bit? You know, that's my understanding of how that works. I don't really use left center eye panning very often because I think stereo is stupid. So I never use it. Okay, then you have what's called Q, CUE, and that is PFL. I don't know why they call it Q, other than, I mean, the term Q is used from the old days of the reel-to-reel tape decks, right? We talked about that last time, but they use Q, but it's PFL. And then they have this on-off button, which is not a mute. It is a channel disable. It kills the whole channel, okay? Then you have the fader, and you're good to go. And there's a meter, which is helpful. All right. Now, where does it go from there? Well, this is where we get a little squirrely. So Yamaha had to hire a computer programmer to program the software for this computer that is pretending to be a mixing console. That's what digital consoles are. They are computers that are pretending to be mixing consoles. Okay.
Computer in a trench coat.
Yeah. So there was a computer scientist that they put in a basement and said, teach the computer how to pretend to be a mixing console. Like, okay, well, what is a mixing console? So they had to teach this programmer what a mixing console is, how it works, what it does, and everything. And the programmer is trying to understand, okay, like, how would I take these concepts and turn them into computer language? And if you understand, anybody do any computer programming? You know any programming languages? A little bit. Matthew does a little bit. So anybody know what object-oriented programming means? Is that a concept anyone's super familiar with? So the idea behind object-oriented programming is that it's a way of optimizing your code, okay? So you can create little chunks of code that are called objects, okay? Or classes, sometimes they call it, okay? And a class is like, okay, well, there is a core bit of code that does something, right? But then there are iterations of that that would have extra little details or do different things. And so that would be called subclasses, okay? And the subclasses more or less do the same. So if I've got a main class of code that I've written that does a certain thing, and I can have two subclasses. Well, the two subclasses mostly do the same thing as the main class, but they each have one little piece of them that's a little bit different. So when instead of right now, maybe I have 4 subclasses, right? And each one of those subclasses has one little thing about them that's different, but other than that, the rest of what they do is the same. Well, instead of writing that code 4 times, I write the main code first for the main class, and then I do what's called instantiating. I can call that up anytime I want. So so I could write a class for the head amp code that controls the head amps, and I just write that, and every time I want another head amp, I just instantiate a new class of it. Great, another head amp code, another head amp code. I don't have to write it once. And then it just sort of like, well, I've got 48 of them. Great, 48, right? I don't have to write that code 48 times, okay? But then you can also build these subclasses. So you can make the one subclass that does that, and then you say, all right, now I have 4 of things that do mostly that, and all I have to do is I just say, make one of those, and then I type the one little line of code that gives it its little special thing, and then I'm done. I don't have to write all that code again. Okay, that's kind of how that methodology works. And so, the person who had the computer programmer who had to write all this code and is trying to figure out how to write the least amount of code possible, because that's how computer programmers think. It's called elegance. And it's a principle that's taught to computer programmers. It's like, you are looking for the most elegant solution. The most elegant solution is the solution that requires you to write the least amount of code and get the job done. That's their goal. They want to write the least amount of code. And it's not because they're lazy. It's because the least amount of code is easier to troubleshoot, easier to debug, takes up less space, is less complicated to read and look into later. So they're always looking for the elegant solution that requires the least amount of code. So this computer programmer is sitting there being taught how a mixing console works. And they get to this part about auxes and groups. Okay? And they're explaining to this computer programmer how an aux works and how a group works. And the computer programmer sits there going, well, those are basically the same thing. And people like me are like, no, they're not the same thing, they're different. But they're kind of the same thing. I mean, they do something very similar, right? I mean, the core functionality of both those things is very similar. You're taking some sound from that little stream, and you're sending it somewhere. Well, okay, yeah. Okay, that auxes do that and groups do that, yes. Okay, it's like the only difference between them is that with the group, it sends all of the sound to that place, but with the aux, it only sends some of the sound to that place. Right? You remember that when we talk about auxes and groups? But the computer programmer's going, well, that's the only thing that's different about them. Is the group sends all of the sound there, and the aux sends only some of the sound there. Well, great. I'm just going to write one big class that is the thing that sends sound to places, and then I'm going to create subclasses. One is the subclass that sends all the sound, and another is the subclass that only sends part of the sound. And then every time we want something that behaves like an aux, we just instantiate the second subclass, and every time we want something that behaves like a group, we just instantiate the first subclass. Elegant solution, required a little tiny bit amount of code to do that, didn't have to create all these little things, right? Great. Well, what do you suppose they called the main class? They called it a mix. Okay? Because that's what this is a mixer.
Right.
Right? And this is where the mixing happens, is in these auxes and groups, right? That's where the actual mixing happens. It's like, well, it's a mix. So it's, because ultimately, that's what's happening, is you're taking bits of sound from all the channels and you're mixing them together into one place. Right? So your main stereo group, that's going to have a mix of all the little channels. Your aux 1 is going to have a mix of all the channels. Aux 2 is going to have a mix of all the channels. Group 3 is going to have a mix of all the channels. Right? It's a mix. So that's what the main class was called, was a mix. And then said, okay, great, it's a mix. And then I'm going to create the subclasses, which just describe the way that that mix behaves differently. And the main difference between an aux and a group is that the group is fixed routing in the sense that you just turn it on and it sends all the sound to that place. Whereas an aux, there's a variable element to it, right? There's a knob that you turn with a number that we don't know, which in a computer programmer language, that's a variable. Anytime they're dealing with a number that they don't know what it's ever going to be, it's up to the user to tell them what that number is. That's a variable in code. That's a programming term. Great, that's a variable. So I'm going to take that spot in the group where that number was 100%, and I'm going to instead replace that chunk of code with a variable that says, get this information from the user of how much sound to send. Okay? That makes all the sense in the world from a programming point of view. But here's where I personally think Yamaha dropped the boat. Or dropped the ball. Sunk the boat. Is they took that terminology that the computer programmer came up with that made sense for the code, and that is the terminology they presented to you, the end user. Which I think was a massive, massive mistake. Because they could have had the programmer just use the terms aux and group, which is what we've been using for 50, 60 years. I mean, these terms have become ubiquitous. And they could have just as easily put that word on the screen. And they wouldn't have had to change any of the code that programmer wrote. But instead, they chose to use the terminology that the programmer came up with and present that in the user interface. And that created some problems. It actually created some massive problems for people like me who have to teach this stuff to people. Because Yamaha then went on to sell 300 billion of these. And then they made other consoles off of this paradigm and sold billions of those as well. which means every single one of you probably learned sound on a digital console that was made by Yamaha. Is that an accurate thing?
Exactly.
Okay. I would put money on the fact that you have all dealt with a Yamaha console sometime before you came here. Okay? And so and that may very well have been your introduction to the world of digital consoles, was you got put in front of a Yamaha console, right? And that was the terminology you were presented with. Which means you were presented with flawed terminology from the beginning. From the beginning of your knowledge experience, which is a huge problem. Because guess what? Yamaha is the only people who made this dumb mistake. Every other console manufacturer did not fall into that trap. Okay? As far as I can tell. Everyone else was smart enough to be like, hey, wait a minute. Maybe we should not reinvent all the words.
And Digico came along.
All right? And so this is kind of a problem. Because now y'all don't know the difference between an aux and a group. Okay? Because from Yamaha's point of view, they're presented as though they are the same thing. And they are not the same thing. They are similar in what they accomplish, but they are not the same thing for why you would choose to use one or the other. They are not interchangeable. Okay? All right, now that I have explained all the reasons why I think this is the stupidest thing in all of sounddom, now let me show you what it actually is. Hey, look, 16 mixes. Mix. I've got 16 of them. What the heck is a mix? Well, mixer setup. Or you go to mixer setup. And what does it say there? Bus setup. Where else do they use the word bus? Anywhere else in this console? Never. Ever. So somebody decided to invent a whole other new word.
Just good.
And put it in there. That's the only place that word shows up on this entire console. Literally nothing else, that word never shows up anywhere else in the user interface, except for the one button you have to push to turn it into the thing that it does. Okay? You push this button and you never see, bus setup, but they're not called buses, they're called mixes.
Mix.
So what exactly am I doing here? Right? God, this is...
Make
So do you
it
like that or GEQs more?
It's close. All right, so here's the deal. We have 16 mixes, or some might call them buses. The term bus is not new. As much as I make fun of them for putting it there, that's not a new term. We've been using the term bus for years in the analog world because a bus was a useful word to describe sort of what was happening with the mixer. It was like you put the sound on the bus and you drive the bus, to where the sound needs to go, right? And it's just a question of, is everybody going on the bus or is only some of the people going on the bus, right? That's the difference between an aux or a group, right? So the term bus was useful, right? Great, we put the sound on the bus and we drive the bus to the speaker where it needs to go, right? And are we taking the whole team? Or are we just taking, the starters, Who are we taking on the bus, right? So that term bus, that's been used for a long time. But they didn't use it here. So what you can do is you have some options on each of these mixes. Your options are vary, which stands for variable.
Yeah, I think it says vampire.
What's that?
From here, it looks like it says vampire.
Yeah.
It does.
No, because I think it says vampire.
So your options are vary / variable or fixed. Now, the variable basically means aux. Okay? So this is an aux. So do you want this mix to behave like an aux, or do you want it to behave like a group? And to describe group, they've used the term fixed. Fixed routing. Okay? Because that's how a group works. Okay? And again, I have no problem with this principle or this concept from a programming point of view in a digital world. I have a problem with presenting these terms to the end user because it's terms that you only see in Yamaha universe. And that's a really crappy thing to do. So do you want it to behave like an aux, or do you want it to behave like a group? Well, you get 16 of them. You get to decide. Do you want 16 groups, or do you want 16 auxes? Or do you want 8 groups and 8 auxes? Or do you want, 12 groups and 4 auxes? You can decide. But you have to do them in pairs. So you can't have an odd number of groups and auxes. You have to have even numbers of them because you switch them in pairs. So if you set it to fixed, that means group. Now that behaves like a group. If you set it to variable, that means aux. But you get to decide the variable piece of it. Is it pre-fader or is it pre-EQ? And that just means that when we put the sound on the bus and drive it to wherever it's going, has it been EQ'd already or has it not been EQ'd already? Right?
Yeah.
That's all that means. Do you want it to have gone through the EQ or not? Okay, if you want it to have gone through the EQ, you set pre-fader. If you don't want it to have gone through the EQ, you set pre-EQ. And then what goes on the bus is whatever comes straight off of that head end. Okay, yes?
Okay, so what about on the analog we had post fader?
Yes. So how does that work?
Would that be?
For some ridiculous, well, it's actually good reason. You don't change that here. This is the part that I'm a little, makes me nervous, is if they had just called it an aux, they can just say, is it pre or post EQ aux? Is the aux pre or post EQ? They should have just used that terminology, because that's what they're really talking about. Because the term pre-fader means something else. Okay? They should have just said, is it pre or post EQ? So if you say pre-fader, then here's what happens, is there's mix 1, and I can toggle it pre or post
Oh, okay.
on a channel by channel basis, just like on an analog console. Okay? So at the moment, I have this configured to be essentially 16 auxes. Okay? But I could instead say, well, I just want half to be groups and half to be auxes. Okay? There we go.
Take to the wheel.
And now it's much more illustrative if you look at it over here. But look here, I have the first 8 of these are just buttons, right? The sound either goes there or it doesn't, just like a group. Okay? Or it's a knob, which is an aux. So I have 8 auxes. And I can hit this and I can say, well, is the aux pre-fade or post-fade? Right? And I can do that per channel. Okay?
So when it turns black, then it's post.
Right.
Gotcha. Okay.
It's not pre.
Right.
Right. You have to infer that the alternative to pre is post.
Well, yeah. It's just,
It would have cost them nothing to just make the
put it
word
there.
change on the button.
yeah.
It would have cost them nothing.
That would have made sense.
But the word post never shows up anywhere in here. Even though they built that functionality, they just didn't put the word there. Why didn't they put the word there?
We use it for
It would have
bus.
cost them nothing to put the word there. Nothing. Okay? Anyway, all right. There you go. So you can have whatever you want. Now, what's my rule of thumb for when to use an aux versus a group? You remember? We talked about it before.
Auxes would usually go on the monitor? Or direct?
So groups are for things that the audience hears. Auxes is for things that the audience doesn't hear, or the audience shouldn't hear. Yes.
So do you do your reverbs on groups, or do you do them as?
The audience does not hear the reverb send.
Oh, fair.
The reverb processor hears the reverb send, right? So anything that is not being sent directly to the audience goes through an aux. Anything that is sent directly to the audience goes through a group. Why is that distinction important? Well, because you're going to be moving faders up and down, right? And you know, when you move this fader up to -10, you darn well better be sending -10 to the audience, right? Because you're going to be standing in the audience, okay? Hopefully. So you don't want to be sending things to your audience through an aux that could be doing something different than what you're doing with your fader. That would be that would be shooting yourself in the foot, right? And I have seen this happen, where people have done that wrong, and they are sitting there moving faders all over the place, and nothing is happening. And they have invented this whole fantasy in their mind of all these things they imagine is happening to the sound. None of it is happening. Because they used an aux when they should have used a group. Okay? So it's very important that, now, because there is a camp, and I understand where this comes from. There's a camp that says, well, you don't even really need the groups, because you can just you can have them all be variable, have them all behave like auxes, put them into post-fade mode, and set them to unity. And then they behave just like the groups. And the reason that that is the case, the reason that that practice has come to be, is because of this stupid interface thing, where you don't know where to change that. Why would you ever think to change that? Because it defaults to them all behaving like auxes, and there's nowhere in the user interface where it says this is where you change the mixes. Because maybe you have the presence of mind to think that those could be changed. And maybe you get to the point where you're thinking, well, okay, that happens in setup. But when you go to setup, you don't see the word mix anywhere here. You see the word bus. And maybe you know what that means, or maybe you don't. But if you are a brand new person learning this in high school, you don't know what that means, that's what that means. And the person teaching you doesn't know that that's what that means. And so no one ever tells you that that's what that means. And so you never have the presence of mind to actually click that button and see what that does. And so most people have just gotten in the habit of being, well, it just defaults to that, and so they're all just that, and that's fine. And I can make the sound come out, and it works, okay, and people don't shout it. Okay? But you're missing a big opportunity there to actually take control over your signal, okay? All right, questions? As you can tell, this is a very passionate subject to me. I think that Yamaha ruined an entire generation of sound people with this mistake. And it has caused people like me a lot of problems, because trying to reprogram your brains back to the thing that we've all agreed on for the last 60 years is very hard, because you learn it wrong first, and then I have to fix it. And it's very hard to fix it. Okay, so everybody get it? If you don't get it, it's fine. I will give the whole speech again if I have to. Everybody get it? Connor?
So, for a group is anything the audience hears, yes. So like.
Well, that's what you use it for.
Right. Yeah. And so like in any, your underbalk delays would be their own group, or is that just, it's actually the main left-right bus?
In Annie,
it's delayed.
In Annie, I have a group that I call vocals.
Okay.
Okay? And all the input channels that have vocal mics get routed to that group. That group then feeds through what's called a matrix, which we haven't learned about yet. And that matrix takes that signal and sends it out to lots of different places with different delays and different EQs and different levels. So that's a different concept. We haven't gotten to yet, but we will get to someday. But yes, it does go through a group.
Okay.
But the difference between center cluster and front fills and balcony fills, that's happening in a matrix.
Okay.
Yes, you can do that, yeah.
So then, but then like anyone backstage who's getting like a program feed is just a post-fade aux then?
Yep.
Okay.
That's going through a post-fade aux because I don't want them to hear the voice if the fader's down,
Right.
right? Yes. So I have a post-fade aux that is also called vocals,
Sure.
that contains, a blend of all the vocal mics, but it's post-fade. And then, yes, I route that to monitors backstage and stuff like that.
Whoever wants to go
Yeah.
backstage or whatever.
Yep, and the idea there is because it's an aux, I can rebalance it a little bit, because what blends out here in the audience doesn't necessarily be is not necessarily what will blend on a monitor backstage when you're standing 2 feet away from it. And so I want the ability to have some people be a little quieter in that monitor mix than they are necessarily in, because their voice is pointing out to the audience. And so sometimes their voice comes through really great in the house, and I don't have to put as much sound out of the speakers. But backstage, that's a whole different story. Their voice isn't pointed there. And so I might need more out of the monitor from them than I would in the mix in the house, right? So that's why I would feed that through an aux.
Okay.
Yeah? Other questions? Okay, so now that we understand that, let's talk about where the sound goes after that. All right, so I'm going to give myself, I'm going to do it the other way because this will make it look more like an old analog console. We're going to do it so that we've got 8 auxes and 8 groups, okay? And then you have to decide where the sound goes once it's in that mix, okay? Where is it at that point? Well, presumably you want to have it come out of the console, go somewhere, right? So you do that using what's called it could be a lot of things, but if you don't have expansion cards or anything, it's probably going to be using what's called the Omni outs. And you have 16 of those here, 16 XLR outputs that are just called Omni outs, 1 through 16. They can collect the sound from anywhere that you want them to. They can collect it from the mixes. They can collect it from the direct outs. They can collect it from the insert sends. They can collect sound from anywhere they want and send it out. You do that using the output patch. So the first thing you do, if you go to setup, there's this thing called output port setup. And this gives you the ability to look at, you've got Omni 1 through 8. And I don't know if I can do that up here or not. Can I do that up here? Output port. Here's the output port. So this is Omni 1 through 8. So you can add delay to the output. And you can do an attenuation on the output that is independent of what you're doing with your interface here. You can invert the polarity on the output. But you can also, from here, you can actually say which signal is going to come out of that output port. So like I can say mix 1, or Omni out 1 is going to actually get the signal from mono center cluster. There, right? So there's this little group here called mono. You always have that. You can never not have that. So I could send sound to that, and I'm telling Omni out 1 to, hey, go get the sound that's, go pick up the bus that's, doing the mono thing and send that sound out this port. Okay, so this is called soft patching. So instead of getting a cable and moving things around, you're just programming, say, this sound comes out of this port, this sound comes out of that port, this sound comes out of that port, okay? A little thing to know is that these settings are not recallable. in the console. I mean, the patching is, but all this other stuff, the delay and the attenuation level, the clarity, is not recallable with the snapshot, which is why you can still see there's delays on these outputs, because someone had delayed them at some point, but then, you know, it never reset them because the scene doesn't reset them. Now you have to turn on the delay in order for it to work, but so for that 10 millisecond delay, I'd have to turn it on, but the values are still there.
Is there a reason that it doesn't recall, or is that?
Yeah, because this is their attempt at giving you a little bit of system processing. And system processing is like balancing across multiple loudspeakers that might be fed by separate outputs. You can compensate for time variances in the air, polarity inversions on a wire, and those shouldn't change from moment to moment in the show. I mean, those are system things. And you wouldn't want to change those from moment to moment in the show or from show to show if you're using different scenes for each show, if you're doing like a reps thing or something, right? So those are things that would stay where they are. Okay. But when you recall the default snapshot scene, they just do these one-to-one. Okay, so mix one comes out of Omni one, so on and so forth. And if you, there's another way of looking at it. If I go to output patch here, you can see here are the Omni outs on the top, and here are the mixes. And I've got 1-to-1 going all the way through to mix 12. And then mix 13, 14, 15, 16 are patched to what are called FX buses, which we'll talk about in a minute here. But, and then the stereo outputs, stereo left and right, stereo left and right are patched to Omni 15 and 16. And if you look on the back here, you'll see that I have two XLRs connected to, well, this, Matthew did this, 15 and 16, and those are going into our little monitors here, okay? That's usually the default. Mono is currently not patched to anything, it looks like. But this is, you can patch, soft patch here on this screen on the computer, okay? If you get that set up. Make sense? Are you with me? All right. Just as a gee whiz thing, you can do the same thing with inputs. So input 1 does not necessarily have to feed to channel 1 on the console.
You could go from Dante to, or whatever color.
Well, it's not so much that. It's like, okay, well, maybe you've got all these XLRs patched in, and it goes through some house wiring or something, but maybe you're doing a show today where you want everything laid out in a different order. You don't have to go back in here and repatch a bunch of cables. You can just reorder everything here, right? So maybe you want the signal patch into input 1 to actually show up on channel 20 today, just because based on the show, that's, you know, because it could be like maybe you're coming in to do like a one-off in the middle of a show that's running for a few months, and they've got, you know, inputs, what, 41 through 48 are not used for the show, but those are available for you. Well, you could patch your mics into there, and then soft patch those inputs to inputs 1 through 8 for your show, so you could mix on 1 through 8, just because your brain would hurt less. And you wouldn't have to screw anything up for that other show, right? They just recall a snapshot and gets back, okay? Okay, that's how that works. Now, let me make sure. Guess what? Because this is digital, and digital lets you do things without costing extra money. Here is the overview for my 16 mixes. Look, I get the 4-band EQ. I get the 1 dynamics processor, not 2. I also get an insert, which insert just, you have to pick a couple of inputs and outputs, and you, instead of using a fancy cable, you just, in the software, say, send and receive, right, out to the thing. You have to chew up a couple of inputs and outputs to do that. Then you can either have it go straight out to the Omni port, right? Or you can say, you can turn it into a subgroup and say, well, route it to stereo. Just like we had in the other one. Remember that? So you can turn these into subgroups if you want to. Okay, and they don't have to go out to the Omni port. Dirty little secret, they could do both at the same time.
And
So-
to get to this,
This is just the mix overview
Oh,
window, which you can get over here too by just pulling up mix 1 through 8 on the central logic, or 9 through 16, and you can get all those settings. So you can, yep, you can route it into stereo, and now it's a subgroup, right?
Cool.
Okay. How we doing? Everybody okay?
Yes.
All right.
I'm feeling lightly confused, but I'm not sure where yet, so
Okay.
I'll see if it solidifies.
Should we take a 5-minute break and let everyone's brains settle for a second, and then, let's do that. Take a 5-minute break. If you need to use the restroom or go get some air or something, come back, and if any of you realize, oh wait, I don't actually understand something, because I'm about to throw some new information at you.
are we allowed to, are you gonna take a break too, Jason? Cause I was gonna, okay. I was gonna.
Oh, I'm sure you can go with that. Because I had, like you said, like, this is like, acapella, and like that terminology with mix and everything.
My teacher had always told me they used to learn vocab.
Because I think, no one told me.
I don't know how many, but because we use Yamaha, but I feel
Some amount of confusion here.
that has the.
So like they're just going straight from mix 1 to Omni 1.
I don't know, I don't remember.
It's a Yamaha.
Okay.
Yeah.
Oops, sorry. No, you're good.
I still appreciate the board, but I think that, a good amount that's a little too convoluted and.
I think I'll feel better when he goes over matrices.
Yes.
I think when he goes over matrices,
Because Corey and I were talking and I didn't realize what the
That'll-
fuck was until we
Yes.
just talked so much that was like.
when he talks about matrices, I think that'll help me crystallize my confusion.
Well, I guess what's confusing about it, or just all of it?
I get specifically like, I'm not. The Omni outs, I think, is what I'm vaguely lost.
The omni outs, I think you just have to think of as something like separate from what's going on inside the console, right? Like the omni out is just an output, right? So like all the mix stuff is like digital inside the console stuff that you can do whatever you want inside the console with. And then the omni is the physical thing at the very end of the console, or at the end of the signal chain.
Yeah, so these XLRs, Omni outs on the back, they have little chips on the back of them. Separate processing from the main processor in the console. And you can access that processing and do things like delay, invert the polarity, adjust the level. And you're controlling the port itself.
So the way we have it right now, like mix 1, if you put something in mix 1, it's just gonna come right out of that, of Omni 1?
Yeah.
Okay.
Yeah,
Because that's how it's patched.
that's just how it's soft patch. But you could make mix 1 go out from anywhere you want.
Okay. I think I'm okay.
I have a question.
Yeah.
What is the benefit of using the external DC power supply as opposed to the AC one? Because I've never used the DC one in this.
Good question. So there's a couple of things that happen here. Generally speaking, the console uses DC. Okay. And so, and all computers do.
Yeah.
Right. I mean, everything. Inside. It's DC direct current. So you always have to convert that from alternating current to direct current. You have to have what's called a power supply in there that converts that. Okay, it has a big transformer in it and stuff like Well, those things are really obnoxious. They are noisy, they generate a lot of heat, they can fail, they can pick up garbage off of the line. So using an external power supply like that can help in the sense that all that heat nonsense and noise nonsense and all that stuff is happening in another box somewhere.
I gotcha.
Okay, and then what feeds into the console to power the console, like it's all that garbage has already been dealt with. Okay, and so that's kind of the benefit of that, is it just takes all of that out of there. Which means if you do that, then the fans here don't need to be as aggressive to keep the thing cool. You're less susceptible to power surges at the console. You know, like if you zap the power supply that's in here that converts to DC, you got to take the console apart.
Yeah.
Right? But if that gets zapped, that's a lot easier to replace than the internal power supply of this thing, right?
Okay.
So it cuts down on heat, cuts down on noise, cuts down on, it builds a little bit of fault tolerance. So. Anybody else think of any other questions?
Can we go over, the other 4 of the dynamic types? I mean, the other 2, because I see the compression expander, and then there's, I think 2 more?
Gate and a ducker.
Ducker.
Yeah. So the gate is an automatic mute button. So let me see if I can demonstrate how that works. So I'm telling the Smurf, mute the quiet stuff. So in this scenario, it's like I only want the mic to be on when the mount is hitting the drum.
Mm-hmm.
And every other time, I want it to be muted. So I'm setting this threshold to say, okay, at what point, how loud is the drum when it gets hit? And ideally, I want this to be basically as high as I can get it, because the higher I can put it and have it still work, then the more noise and bleed I can reject. The more often it'll mute.
So the threshold is like the main.
Yeah.
For this.
So what's happening here is I'm saying anything that is louder than minus 15 dB, unmute that. If it's quieter than minus 15 dB, mute it. And so the little red line that's dropping down, that's it being muted. Okay? And right now there's a fade to that. But I can adjust that, like I can make that be immediate.
Ooh.
And I can turn the hold down as well.
Oh my.
Right? But if I do a little decay on it, then it'll slow down the mute a little bit, right? So I can hear the whole hit.
Got you. And you said if it's quieter than.
Right now it's quieter than 15, but I can change that to whatever I want. Okay? And then there's this thing called range, which is like when I say mute, what do I mean? Do I mean really kill it completely? Or do I mean just turn it down a lot, And kill it completely, I set it to infinity. But sometimes I just want it to be, I mean, you've been doing dB keying in Sound Gym, right? I mean,
Yes.
20 dB quieter is a lot quieter, isn't it?
Yeah.
Okay? So if I set this to 30, I mean, that's a lot quieter. May as well be muted, right? So what this would help for, like, a lot of times on drum kits, you end up with a few mics on it. Like on Annie right now, I've got a mic on the kick drum, I've got a mic on the snare, and I've got 2 mics overhead. Well, when the drummer hits that snare drum, it gets picked up by the snare drum mic for sure, that's right, but it also gets picked up by the overheads, probably even gets picked up by the kick drum mic. And I don't necessarily want to hear that snare
And all of
coming through all these things, but I also don't necessarily want the snare drum mic picking up the cymbals and the toms and all that kind of stuff. So if I fine tune the gate, then that mic's muted only until the snare drum is hit. And when the snare drum is hit, that's the only time that mic is active. And so I don't have to worry about that snare drum mic picking up the cymbals and other nonsense, which is very important to me because my drummer's in another room. And I have to make the drummer sound like they're in the pit. And, you know, if I'm hearing that drum over and over again through 4 different mics, it's gonna be harder for me to localize it. And Connor heard it, and he was surprised that, you know, when he heard it, it's like, wait, I thought Jason said the drums were not in the pit.
I didn't see them in the pit. And then they sounded like it was in the pit, and then they wasn't in the pit.
Yeah. Okay, so that's how I'm doing it, is gates. One of the ways I'm doing it to clean that up is I get really tight control over each of those drum sounds that way. Okay, so that's what the gate does. The ducker, let's see if I can actually, I'm gonna do the ducker on something else. Yeah, so I'm gonna, let's see, switch it to, why is it not? It's not syncing. Okay, so on the ducker, I'm gonna say threshold, we'll say 26 for now. Range, I just want to duck it 15 dB. Okay, and you see where it says key in? So the key in is what is the sound it's listening for to know when it has to duck this beat?
Yeah, you're on a gate.
Duck. Okay, so you see where it says key in? Key is what signal are we listening for to know when to turn this down? Right now it says self. The source is self. Listen to myself to know when to turn myself down. That's not super useful for a ducker. Okay, a ducker is like, I talk into the mic and we turn the music on, I talk into the mic, okay? So what I'm gonna do is I'm gonna set the source to be, let's see, channel, oh, I can't do 1 through 8, it has to be an adjacent one, looks like. Let me see if I get any other options here. Ah, yes. Okay, so it has to be a channel that's in the bank of 8. So just to simplify things really quickly, I'm gonna soft pass channel 8 to use input 9 instead. That'll be the mic, okay? Check, check, check. There we go. Okay, good. There we go. Okay, so I'm going to tell Ducker to listen to channel 8. Hello, hello, hello. Please turn the music down. Oh, I can turn Ducker on. Sorry. Ducker is on. Okay, well, it's ducking already, so this just tells me my threshold is too low. So, back over here. There we go.
Your release is super long.
It is really long, isn't it?
The
the hold. Okay, here we go. Paging audience member, blah, 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 blah. You left your cell phone in the theater. Alright. Once again, please come get your cell phone from the front desk. Yeah, duckers are used all the time in restaurants.
Wow.
So you don't have to have something you have to like say, guest number whatever, your table is ready. It's a ducker! Okay. There you go, that's a ducker. Then, off the key. Compressor we've learned about. Compressor is just turn down the loud things, which is actually going to be easier to demonstrate using a drum. So, I'm just saying, I'm gonna turn my threshold down, say, hey, if it gets louder than -24, turn it down. The ratio is turn it down by how much? Turn it down a lot, or turn it down a little bit. How quickly do you turn it down is the attack. So if I make the attack really short, and the release is how quickly do you turn it back up again once it gets quiet. If I make both those really short, it sounds like I added reverb to that kick drum. Why? Because the initial kick is really loud, but then it's got that tail to it, right? And that tail is being turned up, right?
You said attack is like how fast?
Attack is how quickly does it turn it down. And by quickly, I don't mean like how soon. I mean how long does it take to complete the fade down. It starts fading immediately. It's just how long does it take to fade. Is it a 5-second fade? Is it a 10-second fade? It's in milliseconds, so it's much quicker. And then once the signal drops below the threshold, gets quiet again, how long does it take for the Smurf to turn it back up? Is that a long fade or a slow fade or a quick fade? Right now I've got both set to really quick, which has the effect of sounding like there's reverb on this. Okay? There's a compressor. Expander.
It's me.
So knee is this very meta thing for people who really like looking at graphs and get paranoid by graphs. But a knee is about this transition between the compressor doing nothing and the compressor doing something. So is that, you can soften that out a little bit. So there's a little bit of a laziness to it. But quite frankly, this feels like something that makes people feel better that like to look at pictures. But I have never in my entire life of doing this for longer than you've all been alive, I've never once felt like that compressor knee is just too sharp for me, Like my ears have never told me that. My eyes may have told me that a few times, but my ears have never told me that.
So being that attack is how long it takes to fade, release is how long it takes to come back?
Yep. Yep. So expander is turn up the loud things. So what you notice here is if you look at the difference between in and out, it's coming out louder than it came in. Right? Because when the drum gets hit, ooh, that's a loud thing, turn it over. All right. There you go. There's your 4 dynamics processors. All right, other questions?
Did you answer the two odd beam one?
The what?
If, button if you get to two of the, at the same time for the code.
Oh, what you were asking about, can you have one fader control, one of these central logic faders control more than one channel?
Yes.
Okay, I've not answered that yet, but I will answer that a little bit later. Okay. The answer, by the way, is no, or kinda. But mostly no. All right. Okay. Let's talk about effects. Okay, because remember last time when we had used this little reverb thingy to put reverb on the signal, right? And how did we do that?
We patched this up to the console.
Yeah, but how? What was that patching process? What sort of capabilities of the console did we use? What outputs did we use? What inputs did we use? How did that work? Anybody remember?
Insert, yeah.
We went out of an aux, right?
But then
You're right.
So we chose and what sort of aux was it? Post-fade aux. So we picked a post-fade aux, and we plugged the input of the reverb into that output, right? So that aux output feeds the input of this reverb, okay? And then reverb gets created. And then reverb comes out of this thing, and then where does it go?
out of the channel.
Yeah, it goes into some channels on the console that we can mix, right? And now, because that's new signals we've created, right? Okay, well, in the olden times, this is how we had to do this. We had to get an external reverb processor, we had to do what we just described. But now that things don't have to cost things, in digital world, you can add that functionality. So there is this little button here called rack. And the rack is your pretend rack of equipment, of extra equipment. So here's the rack. Okay? So I have an 8-unit rack, virtual rack. Okay, just like I've got this rack over here where I racked up a bunch of external processors that I wanted to use. You have a virtual rack, and that rack can have up to 8 things in it. And what would you like those 8 things to be? Well, Yamaha thinks that you're going to want 4 graphic equalizers and 3 reverbs and 1 delay processor. And when they say delay, they mean echo. Okay? That's what Yamaha thinks you want in your rack. I can tell you right now, I would never want 4 graphic EQs in my rack, because I think graphic EQs are the devil's plaything. So I would never want those. But you get them anyway, whether you want them or not. But you can change it. I can, at the very least, I can just say, I don't want those at all. It'll give me a 31 band graphic EQ, or it can give me a flex 15. I don't even know, what does that even mean?
It looks like it probably gives
Like a stereo or something?
well, it splits it from being a true stereo to
Oh, to 2 separate ones, yeah. Of course it does.
Because we definitely want that.
We do not want that. Yeah, so you basically, your rack of 8 things, 4 of them have to be either nothing or a graphic EQ. Which is a wasted opportunity in my opinion, because graphic EQs are the devil's plaything. And the reason they're the devil's plaything is that I understand why people like them, because back in the olden times, before we had things like these graphs that showed us what we were doing with the parametric EQ, the graphic EQ was really cool because you could move all the sliders and you could kind of get a picture of what you've done to the sound, right? That's why they became popular. Oh, I can like draw my frequency response. Okay, good. Well, you're not actually drawing your frequency response. You're just drawing the approximate shape of a filter. But here's the problem, is each of those little sliders gives you, so let me goof around with these. Holy moly. I'll do it here. Okay, so I'm moving it, right? See that? Well, each one of those things, will it give me a bigger view? Oh, yes, excellent. Okay. So I'm moving it. I'm grabbing 1 kilohertz, and I'm moving it up or down. Well, okay, you move this one little thing, and you're thinking, oh, I'm just moving this one little thing. I am controlling 1 kilohertz. Well, what actually happened? I lost a whole bunch of stuff, right? I did not just lose 1 kilohertz. I lost, looks like it started reducing as low as 400 hertz and went as high as 3 kilohertz in the frequencies it's affecting. Okay? These things are nowhere near as precise as you imagine them to be. Okay? You think, oh, I'm just going to move that one slider down and I'm going to get rid of that one frequency. I am not. That is not what you were doing. And so what happens is people are like, oh, this becomes, for people who don't understand how feedback works, they are going to say, oh, well, you can use this to get rid of your feedback, because feedback is a frequency that's gotten out of control, and I can just get rid of it. If 1 kilohertz starts feeding back, I can just get rid of 1 kilohertz. And great, 1 kilohertz is not feeding back. Well, guess what you've just done? You have manipulated 2 full octaves worth of frequencies in order to remove a sine wave. That's a big deal, right? You think you did this surgical thing, but in reality, you just messed up 2 octaves worth of frequencies. And that's not cool for me. Like, that's a lot. That's a lot of frequencies to manipulate to get rid of a sine wave. I'd much rather solve that problem another way. So the other thing that is happening here is not only are these things not as precise as you think, but they also are not as isolated as you think. So look what happens when I reduce 800 hertz. 800 hertz is taking most of the same frequencies as 1 kilohertz does. These things are nowhere near as surgical as you imagine them to be. They're terrible. Yeah, they're the worst. Don't ever use these. They're just the worst things ever. I understand, okay, so here's what I get. I get that, okay, maybe you're a person who's doing corporate sound somewhere and you go into a big ballroom and you've got, 5 minutes to set this thing up, and then you got to have a bunch of talking heads with mics on a table and everything, and you got to just get through the night. And you don't have time to move mics or, which is how you really solve feedback, is move the mics. You can't do that, but you got to get through the night. And no one really cares how good any of this sounds. They just want to hear what these people are saying. And if it sounds like crap, nobody cares as long as they heard the words that came out of the person's mouth, okay? Well, in that scenario, this graphic EQ can get you through the night, right? If 1 kilohertz starts giving you trouble, yeah, fine. Go over there and take that out. You just obliterated 2 octaves of frequencies, but yeah, it's not feeding back anymore, and yeah, they can still hear it. But it sounds terrible. And that gets you through the night, and no one's shouting at you anymore, okay? But I just don't live in that world. The world I live in, I do projects where I have more time than that. And I get complete control over the system, so I can put the speakers and the mics wherever I want to put them, and I can go to the people on the stage and say, like this happened on Annie 2 days ago, we did the preview, and one of those little orphans came out and sounded very, very different. And after the show, I went to the A2s, I'm like, what, did something happen? Like, oh yeah, she decided she wanted to wear it over on this side of her head instead of here, because of the hairdo. I'm like, no! Tell her to put it back. I decide where the mic goes.
These children get no choice.
That is my job. I decide where the mic goes. They don't decide. And I said it goes here. Tell her to put it back there. She is not the decider of where the mic goes, right? So I have control over things like that in my world. But I understand in some people's world, they don't have control over things like that. And therefore, sometimes this may be their only tool. But boy, it's a tool that comes with big consequences. So I understand why people like them, and I understand why manufacturers give them to people, even though they're just the worst things ever. There's way more effective ways of dealing with those kind of problems. Okay, but let's talk about this reverb thing. So I've got this reverb hall thing. Look at that. Now I can say, let's take a look at my bus setup. Do you remember what my bus setup was? I said that mix 1 through 8, we're going to behave like auxes, and 9 through 16, we're going to behave like groups. So I need an aux to feed into this reverb, okay? So I'm going to go in here and say, well, I'm going to use aux 8, which is called mix 8 here. So mix 8 is going to feed into that reverb. Do you want to change the hash? Yes, that is literally what I just told you to do. Okay, great. So the sound comes in off of mix 8, it gets reverbed, and then it comes out. Where do I want it to show up? Well, right now it's saying, I've got these 4 channels, stereo 1, 2, 3, 4, that actually don't have, no, they do. So there are physical 4 pairs of XLR inputs here that can be used for those, but you don't have to use them. Instead, I could say, yeah, instead of this thing using physical inputs, I want to patch the reverb, the virtual reverb processor into this channel. So that's what's going on. So here's my mic. Let's see what happens here. If I go into here and I set this to post fade, let me select the right thing here. Somewhere there's a setting that will do this. Okay, so I've set aux 8 to post fade. See how the pre is off? That's how you know it's post. I don't know why they couldn't have just said post, but. I'm going to turn it on, and then I'm going to route some of the signal into that, okay? And I'm going to bring the reverb up, and I'm going to bring the mic up. Check, 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 and I'm getting a reverb. And you can see it over here. So, check. You can see the little meters going in and out on that. I should be able to open this up. Okay, here's the reverb processor. Hello, hello, hello. Right, it's coming in on 1, going out on 2, or left and right, going into the stereo in left and right. And I can control whether the reverb is heard or not by manipulating that stereo return. Okay, so we're doing the exact same thing we did before in the analog world. It's just all done with virtual wires and virtual equipment. Okay, but the signal flow process is the same. You're still chewing up an aux to collect that sound and send it into a reverb processor, and then taking the output of that processor and patching it into an input on the console. It's the exact same process. You're just doing it with computer code instead of cables. That make sense? But the cool thing is, I have, like, let's say I don't like this reverb. And they're like, well, is there a better reverb here? Sure. Let's just pull up this whole library. Look at all these. How about I do this one, reverb stage. There we go. How about this one? Hello. Yes, I like that one, much better, thank you very much. And it can be as simple as that, but you also can control the parameters of the reverb, right? So you can go in and adjust the reverb time, so that just like you could on this thing, but you actually can see the controls better in the software because you're not constrained to this 1U form factor in the rack. So there's some benefits that come from these digital processors. This is super, super useful. There's a whole market now that well, because, all right, you're a mixing console manufacturer, like Yamaha. And I'm giving Yamaha a hard time about this whole mix bus thing. But I generally, I mean, they do make, their stuff is fine. You know, this is a great console. I have personally done a lot of shows on this console. You have probably personally done a lot of shows on these consoles. They are fine. They work well, they are reliable. I've never had one of these crash on me, ever. And the same cannot be said for some other digital consoles I've used. I mean, these things are rock solid, okay? They're great for what they are. But they, you know, Yamaha, they've hired somebody to program these reverb processors, and these are not the awesomest sounding reverb processors. There are better reverb algorithms out there that have been patented by the people, and you can still do that process. Like Lexicon is famous for their reverb. They're great reverbs. We can still use this if we wanted to. We could just hard patch, just like we used to do before. But you know, let's say you're Lexicon, and you have a great reverb algorithm. In the time when this thing existed, Lexicon could say, well, hey, you know, they've got those card slots in there. What if I made a card that had a chip on it that had my reverb algorithm? And then we could stick that in there, and then you could have Lexicon reverbs on your console. Wouldn't that be cool? And so that exists. Like, you can buy processing cards for this console and for most digital consoles that give you third-party reverbs and processors, stuff that maybe sound better than the ones that came with it. It's interesting because Yamaha is sort of their own little behemoth, but you know, you look at other companies like Soundcraft and Allen and Heath that are part of these larger conglomerates. Like Harman, for example, owns like a lot of these different brands. And so because they're all part of the same parent company, they can use each other's technology. So in Allen and Heath digital consoles, they put BSS processors in them. So BSS makes a great dynamic EQ, and you can have that in an Allen and Heath console because they're owned by the same company. Okay, so that's kind of interesting. There's a benefit to buying a console from one of these manufacturers that owns a lot of similar companies because they can share technology. You don't have to buy a third-party card for it. But somebody like Digico that is kind of like, they are a very small company in the UK that just makes these little consoles, and they don't really, that's all they do. They're not affiliated with other things. And so, you know, if you want to have Lexicon reverbs, for example, in your Digico console, you're going to have to buy a third-party interface for that, for the third-party card, okay? But you can do it with digital now, which is really kind of cool. All right. How are we doing? Any questions? All right, I'm going to let you get up and, this is all I'm going to tell you today about this thing. So I'm going to let you get up and play with it now. So just come up and goof around and see what you can make this thing do. I've now told you everything you need to know to get sound into it and get sound out of it. I've told you a couple of cool things. There's a lot of things I haven't told you, but we'll talk about that next week. But I'm going to give you a half hour to just come and play with it, okay? See what you can make it do. And then you can ask me questions and do whatever you'd like to do. But please don't be afraid to touch it.
Touch me. Fingers. So what if I want
You can make the fingers fight each other.
Okay. And then
So in terms of
these
customizing.
are defined keys, so this is how we make it switch to, yep,
one, I've never used it myself, but.
hello, but this is the music. Okay,
They're nuts.
Yeah, it's the same thing with the Dimitri stations.
if I click
Yeah.
this.
Yeah.
Oh, I forgot about the icons.
And then you can change the
You
name.
can change, yeah, you can do that
And
too.
you can name them.
Yeah.
Well, I don't know in this one how you name them, but in the other one we have a keyboard.
Anything
You just
but
go and type.
Yeah.
Well, yeah, I don't know.
It comes up.
Yeah, you can't
Oh, there it is.
open that thing up and turn it on and do a
Wish
show
they had
button.
the
It's
like
like-
currency of color.
Yeah, that's what I
Yeah.
had, the little light.
I know a lot of the
lights.
newer ones have that,
Yeah.
and I mean,
Mhm.
I like that they give you a nice little space to label things, but
We don't use none of these.
By the way, they make a 32 channel version of this that doesn't have this little chunk on the side.
it's the one.
We have two of those. We have one of these 48s and we have two
They
32s.
also make a little sound bridge that goes above the screen, right, with little meters.
Yeah, so the 32 channel one we have has a meter bridge.
Yeah.
What's that?
I don't know.
That's the Omni.
Oh,
Am I going to?
Ooh,
Feels neat.
fancy. There's more Omnis. Mhm.
I want to rename it.
Yeah, feel free to try to soft patch something. You're really not gonna break it. It's gonna be just fine.
okay, I'm trying to soft patch something.
Feel free to pull up a new reverb.
Pretty hard.
Yeah.
Pull it out.
500 terabytes.
These consoles,
I'm thinking about fucking with it while you're doing stuff.
these are very, very hard to break.
They're also ridiculously overpriced for the
Oh, I
LED
forgot he
ones.
moved.
I was looking that up.
Move that one. I was like, where's that?
Oh, for the little lights,
Yeah,
yeah.
we had, so my school does not have a crazy budget. We had an LS9, which is about the worst board that I can think of to mix a musical on. I'm sure there are worse out there, but
I've
it's just,
I've done a couple of musicals on an LS9. It is
it's
doable.
clunky for sure. I just tried to do as much before the
Make that
show
diagonal.
Yeah.
rather than,
I don't
you
know.
know, during.
Let's see what we can.
But I was looking for a replacement light because it was
I'm gonna
dying
play with the different reverbs.
and it was like falling apart. And they're like
Oh, those are the-
so expensive.
Yeah. Yeah, they are.
It's not like one little scroller.
Yeah, which is nice.
Also, the cue, you're right about it being just weird terminology with this, because what it made me think when I first saw it was, oh, you can queue up channels and then have them all go on at the same time or something like that. No, it doesn't do anything like that.
Not what it means. It's very annoying.
It is annoying.
We'll talk more about this next time, but one of the things I love about Yamaha consoles is their MIDI implementation is so comprehensive. I mean, like this app I'm running is basically doing that all over MIDI.
Yeah.
I think that's where
And,
the mic is.
and they publish all the information. For somebody who's like a
Conrad, I
real
moved
MIDI
where the
nerd
mic
like
was.
me, I love that. There have been many, like when I did a musical on an LS9, we didn't have, it was in a small space, and we didn't even have room for the LS9 in the spot that it was gonna be in. And I used a little small fader controller, and I programmed it to do the faders. I actually created virtual DCAs using that. It was very, very cool.
That's impressive. How'd you do that?
Snapshots on the MIDI controller.
So if you can,
Oh,
so you
so
can,
like this. Well, because wouldn't you have to send out two
Okay, we're trying this.
MIDI notes
See
at the
if
same
we
time
get
to
some
control a
pitch
couple of different channels?
adjusted? No, is that messing with my pitch?
Basically,
Oh, yeah, it is. Wait, talk.
Is it messing?
You hear
Here,
it?
I can take me out.
So
Just a
you
little
can
bit.
send out like
I guess I can't.
3 or 4 commands all with one fader.
Now it's
yep.
high and low.
Yeah, I'm trying
Anything that can be controlled with MIDI can
Let's
be
see,
controlled with
what
the
if we
TC1600.
to. Let's do put both. pitches.
Only you're clever enough.
can you send
make both
pitch
pitches.
data through like QLab?
Yeah, now both pitches are high.
The pitch shifter.
Yeah,
If you put it,
dual
wait,
pitch.
do one and one.
There's a
Okay, now
BYU that
are we
uses
getting any of that?
It's like those talking Tom apps.
Yeah.
It is, oh my god.
What if we? Let's start that one.
Nine.
What if we're just getting a woo? How do I get rid of more of me? Like regular me?
It's gonna be balanced.
So you've got to take it out of, you've got to unroute that channel from the main group. So unroute it from stereo.
Okay. Yeah. Okay, now are we? No. Oh, I did the wrong one. We're on channel 9. Why am I on channel 9? What happened?
Oh. So those are like the different pages.
Yeah,
Okay,
and like,
okay.
they're kind of lined up the way it
Okay,
is, so
now?
like, they correspond to different.
Would we just get the? Ooh, that's fine. Just getting it. I like it. Okay, what else can we do to me? Okay, what else should we do? Oh, wow. Somebody else pick one. I did a pretty good one. Somebody else can do something.
Symphonic.
Throw a phaser on there.
We can do that next. Okay, so let's make sure.
Turning
So that's in mix A. So let me send some of
Oh no, that's
me to.
this.
Yeah, mix 8's gonna be this guy.
Okay.
So I don't know what we put on it.
It's
We put something
symphonic.
called symphonic.
Try send it and send it again. So it sent channel 1. Yeah.
Okay. Ooh.
What is it?
And that's on this one. So we can. Oh, it's like. Now, why am I getting more of regular me again? Is it because regular me is in the symphonic?
So what you probably need to do is, yeah, but you can actually daisy chain the processors. So like have the output of processor rack 1 feed into the input of processor rack 2,
Oh.
and then it won't go through the channel again. It's just software, you can make it go anywhere you want.
Ooh. Can I move these two? Like, can I switch?
Just change the output then,
So
yeah.
what? Right.
On top? Right here?
Okay, so I want the output of this one to go into. Would it be through the output?
Yeah, so you would say the output of processor 1 passes to the input of processor 2.
So should we patch?
So you're going to do, let's see. So the output will go to, so inserts.
Oh, we have. Mix 1 is the.
Yeah, so what you'll probably have to do is, since you're going out to stereo 2,
Yeah, that's creepy voice, and this one's the symphonic.
so patch the output of stereo in 2 into the symphonic. So that's coming off of mix 8.
Yes.
So it's 2. It's here, right? So instead of going to stereo, you're going to take it off of that. And you're instead going to put it into, it's 8, is that?
Yeah.
So put it into 8. There you go.
So now, no,
We turned up 6, I think.
don't.
No, that's 8.
That's it. So
Oh, the numbers are at the bottom.
Okay.
Okay.
And then, so now the output of, it's not going out to stereo. So now you've just got to go back to your rack. And so it's going through the dual pitch first.
yeah, that's what I wanted to do.
Well, let's make sure that stereo in, let's see. So what is the mic channel you're using?
9.
So 9 should not be going into there.
Okay.
Should only be, or no, is
So it
it?
should be only going into 2.
Yeah, it should
not
only, it
eight.
should only be going into 2 and not 8, you're right. So, there you go.
Ooh, yeah, I got rid of it.
There you go.
So this one is what is this?
Which one is
Sounds like a
symphonic?
chorus or phaser type deal.
I don't think we're in symphonic anymore. I think this is the one you had before that.
Oh, I think it's both of them.
It should be going from the dual pitch and into the. But. Should we add something else?
Sure. Yeah.
All right, we have 5 more minutes, then we're gonna take all this down.
Yeah, something else must be good. I've messed before.
I'm curious about the user-defined keys and what the parameter in here, because I didn't mess with those a ton.
User-defined keys?
Like, yeah, because I don't know if they're the exact same parameters you can change as on like an LS9.
You can, yeah, they're pretty similar. You can make them do just about anything you want.
Yeah, I've only ever used them for like assigning a tempo.
Yeah, so like,
You can do it for that.
So what are these for?
Theater I work at.
there, so all
we
these
have
ones here, you
a
can have them
bunch
set
of
to
MIDI
anything, so say that you
controls
want to like
to control a Q lab.
mute a group or something,
Right, so,
then you can have that like set to that key,
Oh,
so you push
to-
that and mute them all.
Yeah, so basically, any controller parameter, controllable parameter on the console, you can have that button.
And you can even control on
can
there,
also
like you can
do-
open, here, you can open a window.
Talkbacks and things like that routed through
So
the
now,
user-defined keys. Right, so like we have a comm mic that we route into the
Yeah.
comm system from the desk.
those are
during
fun.
tech. So we have that button to turn that microphone on and off, so it's assigned to a channel on off
Gotcha,
for
okay.
our microphone,
Okay,
things like that.
cool, yeah, I'm just haven't messed with those.
So what we're going to talk about next time is we'll get it out again. We're going to talk about DCAs, which is the answer, the version of the answer to your question that can be answered with kind of, right? We're going to talk about a matrix and what a matrix does. And we're going to talk about automation next week, right? Those are the things we'll talk about. And then I will give you your assignment.
Yay.
All right?
Question related to Jess's question, of
Yes.
like, is there a way to like link to? one?
Yeah.
Okay.
That's
Yeah.
a channel job, right?
Yeah, you can go in and tell it to just like link certain faders. So like channel link here, you can say, all right, I want to link, I think it's these two that are the same. So there we go. So now, and you can say, you know, like what parameters do you want to have linked, you know? Like if you don't want the, you know, right now everything is linked. So they're just clones of each other. That was like, oh, I only just really want the fader to be together and the channel on, then it's just fader. Right? And if I turn channel on, then they both go off. Right, so it's kind of whatever, and you can do that to as many channels as you want. Like I can have them be all the same.
You gotta hold it.
Right? So, there you go.
Holding it is basically telling it what channel you want it to link to.
Yep,
Gotcha.
there you go, now they're all off. Yep. Cool. All right, anything else anybody wants to try or ask before we take it down? All right, let's take it down. Stop the recording here.